Consider the sequence of destruction. Mercury would be the first victim. It would not simply be swallowed, but incinerated in a torrent of plasma the moment UY Scuti's photosphere touched its orbit. Then comes Venus, the planet of sulfuric clouds, melting like a wax candle under a cosmic blowtorch. And then Earth. Our atmosphere would be stripped away in seconds. The oceans would boil and vanish before we could even comprehend the red glow consuming both hemispheres. No great bang, just a sudden absolute silence as every single library, city, and memory of mankind becomes a microscopic speck of ash within a stellar furnace. Even Mars, with its deepest canyons and highest peaks, would be as a fragment of dust swept away by a crimson tide. Close your eyes. Now, imagine a mundane morning. You wake up, brew a cup of coffee, and look out the window to see the familiar golden orb of the sun slowly cresting the horizon. But then, something fundamentally wrong happens. The sun is no longer a fitting circle in your field of vision. It begins to grow, faster, larger, an irrational, terrifying expansion. In an instant, the entire sky is consumed by a wall of crimson fire. There is no time for panic, no time for escape, because we have just replaced our sun with UY Scuti, a void-born monster, a red hypergiant whose scale defies every human definition of existence. Look at our solar system. Mercury? Swallowed instantly. Venus? Vanished in a blink. Earth? We would not even realize we had ceased to exist before being incinerated by an unimaginable atmospheric pressure. Even Mars, the distant red planet, becomes a mere speck of dust in the palm of UY Scuti. We often speak of the grandeur of the cosmos, but these are hollow numbers until you place yourself in relation to something like this. UY Scuti is not merely large. It is an insult to human imagination. It is the embodiment of the vertigo we feel before the infinite, a mass of matter so colossal that it renders everything we have ever known utterly meaningless. To truly penetrate the scale of UY Scuti, we must discard everything we know about distance. Travel from the Earth to the Sun. From the Earth to the Sun. At the speed of light, this journey takes about 8 minutes and 20 seconds. It is a distance that defines our entire biological existence, the very baseline of our solar system's stability. Now, imagine that this entire distance, this 150 million kilometer void, is merely a small fraction of UY Scuti's radius. If we were to map the solar system inside the body of this star, the transition would be a nightmare of geometry. You would pass the orbit of Mercury, not as a boundary, but as a mere ripple in the plasma. You would glide past Venus, then Earth, and continue for millions of kilometers more, still trapped within the searing red fog of the stellar interior. By the time you reach the orbit of Saturn, you would finally be approaching the photosphere, the visible surface of the star. Think of the volume. Volume increases with the cube of the radius. This means that inside the space occupied by one single UY Scuti, you could fit billions, literally billions of our suns. It is not just a larger star, it is a different category of existence. It is a celestial entity that has claimed so much of the local vacuum that it has effectively become its own miniature galaxy of fire. When we look at the night sky, we see points of light. But UY Scuti is not a point, it is a territory. It is a sovereign domain of plasma that dictates the gravitational laws of every stray asteroid and gas cloud in its vicinity. To further illustrate this 1,700 solar radius scale, if the Sun were a grain of sand 1 millimeter in diameter, UY Scuti would be a sphere 1.7 meters wide. A grain of sand versus a structure larger than a grown human. This is the terrifying delta of scale. Even if you traveled at the speed of light, the absolute speed limit of the universe orbiting the Earth takes 0.13 seconds, and orbiting the Sun takes 14.5 minutes. To orbit UY Scuti, you would spend nearly 10 hours in a single lap. Imagine the sheer void of space being filled by one single object. It is a predatory expansion, a celestial lung breathing in the vacuum. So, how large is large? Astronomers estimate the radius of UY Scuti to be approximately 1,700 times that of our Sun. Pause for a moment to digest that figure. If UY Scuti were placed at the center of our solar system, its surface would extend far beyond the orbit of Saturn. The entire region of space we call home would be comfortably tucked inside a single star. To grasp this, let us apply a lesson in time. If you were aboard a modern commercial jet cruising at 900 kilometers per hour and you wished to circle the circumference of the Earth, it would take you roughly 45 hours. But to circle the circumference of UY Scuti, you would need thousands of years. Generations of pilots would be born, live, and die in the cockpit, and the plane would still not have completed a single orbit. This is the definition of a hypergiant, not merely a giant nor a supergiant, but hypers, an extreme evolutionary state. UY Scuti is the result of a cataclysmic accumulation of matter and energy, a grand imbalance between gravity seeking to crush everything inward and radiation pressure from the core pushing everything outward. Yet, this grandeur comes at a price. The larger the star, the more unstable it becomes. UY Scuti is like a colossal crystal palace, magnificent but hollow, a fragile structure screaming in the vacuum, struggling not to be torn apart by its own contradictory forces. In the map of cosmic titans, UY Scuti is not alone. There is Betelgeuse, the red shoulder of Orion visible to the naked eye. Betelgeuse is vast, yes, but beside UY Scuti, it looks like a tennis ball placed beside a skyscraper. Then there is Stephenson 218, another contender for the crown of the largest discovered star. The battle for the universe's throne is fought in an environment of extreme noise. Measuring a star thousands of light-years away is not like using a ruler in a laboratory. Scientists rely on luminosity, spectral lines, and complex mathematical models to infer a radius. For a time, UY Scuti stood at the absolute peak, the largest recorded object of its kind. However, astronomy is a science of constant refinement. As precision tools evolved, the 1,700 solar radius figure began to be questioned. Perhaps it is smaller, perhaps 700 or 1,000 times the size of the Sun. But regardless of the final number, UY Scuti remains a monster in the truest sense. The shifting rank does not diminish its awe. Instead, it reveals that the universe always harbors secrets. Whether it is first or fifth on the list is a trivial detail. The core truth remains: UY Scuti represents the ultimate limit of matter a star can attain before its inevitable destruction. Understanding the hollow's nature requires a dive into the physics of red hypergiants. While the Sun is a dense, gravity-compressed ball of gas, UY Scuti is more of an energy bubble. In its outermost layers, the density of matter is so low it is nearly identical to the vacuum of interstellar space. This is the result of extreme radiation pressure. From the core, photons are launched like relativistic bullets, colliding with hydrogen and helium atoms, shoving them outward with relentless force. This creates a stellar wind of such violence that billions of tons of matter are exhaled into the void every second. The surface is not a place, but a transition. A chaotic zone where plasma swirls in storms larger than our entire solar system. A common fallacy when imagining UY Scuti is to envision it as a solid, dense sphere, a cosmic iron ball. In reality, UY Scuti is a hollow monster. Consider density. If you took a spoonful of matter from the heart of our Sun, it would be devastatingly heavy. But a spoonful of matter from the outer layers of UY Scuti would be nearly nothing. You would be holding something akin to a vacuum. Its surface is not a solid boundary or a sharp edge. It is a diffuse cloud of plasma, a brilliant haze extending for millions of kilometers. This occurs because of radiation pressure. At the core of UY Scuti, nuclear reactions occur with such terrifying intensity that they create a torrent of photons pushing outward. This energy flow is so powerful that it drives the outer shell of the star to expand outward, thinning the matter to an extreme. If you could fly into UY Scuti, you would not feel yourself passing through a solid mass, but rather gliding through a searing, luminous fog. The boundary between inside and outside becomes blurred. UY Scuti is not just a star, It is a region of space dominated by a central energy engine where matter is shredded and cast wide in a dance of chaos. Red. That is the signature of UY Scuti. Why not the brilliant blue of Sirius or the pure white of Vega? In astronomy, color is the language of temperature. Blue stars are the hottest, the true blast furnaces of the void. Red stars are cooler, though cool here still means thousands of degrees Celsius. UY Scuti is a red hypergiant. When a star exhausts its hydrogen core, it begins burning heavier elements. This process generates immense but unstable energy, causing the star to swell. As the surface area increases by millions of times, the average temperature at the surface drops. The resulting light shifts toward the red end of the spectrum. But do not let the red hue deceive you into thinking it is weak. Despite the lower surface temperature, because the surface area is so colossal, the total energy, the absolute luminosity that UY Scuti emits, is staggering. It shines tens of thousands of times brighter than our Sun. If our Sun were replaced by UY Scuti, the Earth would not just be swallowed physically, it would be vaporized instantly by the sheer intensity of that crimson radiation. UY Scuti resides within the constellation Scutum, a region of the Milky Way choked with dust and gas. This environment transforms the star into a challenging enigma. The distance from Earth to UY Scuti is estimated between 5,000 and 9,000 light-years. In the cosmos, a 4,000 light-year discrepancy is a chasm, and it leads to fatal errors in calculating size. Imagine looking at a lamp from a distance through a thick fog. You see the light, you see the shape, but you cannot tell if the lamp is the size of a pea or the size of a beach ball, because the fog blurs every detail. Cosmic dust acts as that fog. It absorbs and scatters light, making the determination of the radius a battle of hypotheses. There were times when research proclaimed UY Scuti as the undisputed king. Then a new dataset emerges, a new computational model is applied, and the number is revised downward. This contradiction is not a failure of science, but its beauty. It reminds us that we are peering at an object across an unthinkable distance, attempting to comprehend an entity we can never touch. UY Scuti stands there, in the silence of Scutum, simultaneously flaunting its grandeur and hiding its truth. The internal struggle of UY Scuti is a masterclass in stellar agony. To understand the onion structure of its core, we must look at the thermodynamics of fusion. In a normal star like our Sun, hydrogen fusion is a steady, dependable process that lasts billions of years. But in a hypergiant, the clock is accelerating. As the hydrogen at the center is exhausted, the core contracts under its own immense weight, heating up to temperatures that would melt any material in the known universe. This heat triggers the fusion of helium into carbon. This process is exponentially more violent and far less efficient. The energy produced by helium fusion is so intense that it pushes the outer layers of the star outward, creating the bloated red appearance we see today. But then, the helium vanishes. The core contracts again. Carbon begins to fuse into neon. Neon into oxygen. Oxygen into silicon. Each stage is shorter than the last. The burning of hydrogen took millions of years. The burning of helium took hundreds of thousands. The burning of silicon? It may last only a few days. This is the stellar countdown. UY Scuti is no longer a star in the traditional sense. It is a ticking nuclear bomb. The layers of the star are now a series of concentric fire shells, each one burning a different element, each one fighting a losing battle against the crushing weight of the layers above. The pressure at the center is so extreme that the atoms themselves are being crushed into a state of degenerate matter, where the laws of classical physics break down and only the sheer force of quantum mechanics prevents the star from collapsing instantly. If we could slice through UY Scuti, we would find a structure like a cosmic onion. At the very center is a heavy, stagnant core of iron. Surrounding it are shells of fusion, a layer burning silicon, then oxygen, neon, carbon, and finally a massive envelope of helium and hydrogen. Each transition is a desperate gasp for life. When hydrogen fails, the star collapses slightly to trigger helium fusion. But each new fuel is consumed faster. While hydrogen might last millions of years, the silicon burning in the core might last only a few days. UY Scuti is a luxury spender of nuclear fuel, burning through its reserves in a frantic attempt to stave off the crushing weight of its own gravity. Beneath that serene and brilliant exterior is a struggle for survival. UY Scuti is not at peace. It is in the final, desperate stage of a stellar life. Every star is a ceaseless war between two forces: gravity, which seeks to crush everything into a single point, and nuclear pressure, which seeks to blow everything apart. For most of its life, these two are balanced. But UY Scuti has lost that equilibrium. As hydrogen, the primary fuel, is exhausted, the star begins to burn helium. When helium is gone, it moves to carbon, then oxygen, neon, magnesium. The heavier the element, the faster the fuel is consumed, and the more chaotic the reactions become. The core of UY Scuti is now like a leaking, colossal pressure cooker. Massive pulses of energy from the core drive the outer layers away, creating gargantuan oscillations. The star contracts and then expands, breathing heavy, tired breaths. Each expansion is a desperate attempt to exist, but in truth, it is the herald of the end. UY Scuti is spending the last remnants of its fuel in a frantic luxury before the darkness falls. What happens when the final spark in the core of UY Scuti goes out? The answer is a collapse more violent than anything imaginable. When radiation pressure can no longer fight gravity, the entire mass of the star falls inward. Imagine a structure spanning billions of kilometers suddenly compressed into a tiny region of space in a matter of milliseconds. This collapse creates a maximal shock, leading to a supernova explosion. In a single moment, UY Scuti will radiate energy equivalent to billions of stars combined. The light from this eruption will outshine the entire Milky Way galaxy for days or weeks. It will seed the void with heavy elements, gold, platinum, uranium, creating the raw materials for future generations of planets and life. But at the heart of the explosion lies a tragedy. Once the outer shell is blasted away, what remains depends on the residual mass. If the core is heavy enough, gravity wins absolutely, crushing matter beyond every known physical limit, creating a singularity, a black hole. From a giant that dominated space, UY Scuti will become a monster of a different kind, an invisible void where time stops and light cannot escape. The transformation from the largest surface area in the universe to a point of zero size is nature's most brutal plot twist. Before we witness the end, we must contemplate the terrifying silence that governs the space around UY Scuti. In the vacuum of deep space, there is no sound, only the transmission of electromagnetic waves. But the silence of a hypergiant is a lie. It is a silence filled with the invisible screams of radiation. Imagine the gravitational distortion. An object of this mass does not simply reside in space. It bends the very fabric of space-time around it. If you were to observe the stars behind UY Scuti, you would see them warp and shift, their light bending in a gravitational lens caused by the star's colossal presence. It is a hole in the geometry of the universe, a place where the distance between 2 points is no longer a straight line. And what of the loneliness? UY Scuti is the king of a dead empire. As it expanded to its current size, it likely consumed every planet that once dared to orbit it. The very worlds that might have harbored life, the rocky spheres that might have developed oceans and atmospheres, were all digested. They were melted into the plasma, their minerals added to the star's bloated mass. The tragedy of the hypergiant is that to reach the pinnacle of size, it must destroy everything it loves. It remains a solitary sentinel in the constellation Scutum, surrounded by a wasteland of its own making. It is the ultimate paradox of the cosmos. The more you occupy of the universe, the more alone you become. The red glow is not just a sign of heat. It is the lonely light of a monster that has eaten its own family to sustain its own vanity. When we look at UY Scuti, what do we see? A number? A star? or a mirror of our fragility. We spend our lives worrying about trivialities, small conflicts, personal ambitions. But when placed beside UY Scuti, every concept of large or small, important or trivial, evaporates. Earth, with all its billions of years of history, all its risen and fallen empires, all the love and pain of humanity, is merely an invisible grain of sand in the shadow of a red hypergiant. Yet this insignificance should not bring despair. On the contrary, it brings a strange relief. We are small, but we are the only small creatures in the universe capable of measuring, understanding, and feeling awe at UY Scuti. That a carbon-based organism living on a tiny planet can peer through 5,000 light-years of cosmic dust to recognize the existence of a colossal star, that is the true grandeur. Human curiosity is the most powerful telescope, allowing us to touch the borders of the void. UY Scuti will die, a black hole will consume it, and one day the entire galaxy will grow cold. But right now, in this fleeting moment, that star still glows red in the constellation Scutum, reminding us that the universe is always larger than our dreams, and that true beauty lies in the humility we feel before the infinite. Wait, before we succumb to the collapse, we must understand the silence that surrounds such a giant. Space is not empty, it is a fabric. An object as massive as UY Scuti does not just sit in space, it warps it. The gravitational well of a hypergiant is a profound depression in the geometry of the universe. If you were to orbit this star, you would encounter a graveyard of shattered planets and frozen gas, remnants of a system that could not survive the star's expansion. The transition from the scorching red surface to the absolute zero of the void is not a line, but a gradient of agony. The loneliness is absolute. Of UY Scuti. It is a king of a dead empire. As it expanded, it likely consumed every planet that once dared to orbit it. The very things that gave the star its identity, its planetary companions, were digested to fuel its final, bloated stage of life. It is the ultimate paradox. To become the largest, it had to destroy everything that was close to it. When we speak of deep time, we speak of scales where the rise and fall of human empires are less than a flicker of a candle. UY Scuti's life is a blink in the eyes of the universe, yet it encompasses a drama that dwarfs our existence. The stardust that forms the core of this star was forged in the death of an even older generation of stars. We are, Melihat, seeing a cycle. The carbon in your cells, the iron in your blood. They were once part of a hypergiant's heart. We are the children of these cosmic catastrophes. When UY Scuti explodes, it will not just be an end, but a distribution of wealth. It will throw the elements of life across the galaxy, ensuring that in 1 billion years, another planet, another consciousness, might arise from its ashes. The vertigo we feel when looking at UY Scuti is not just fear of size, but a subconscious recognition of our own origins. We are staring at our ancestor, a monstrous dying parent that must perish so that the universe can continue to evolve. The red glow is not just heat, it is the light of a cosmic forge, preparing the ingredients for a future we will never see.